How to plot scores on the bell curve. So far, this semester we've discussed second language acquisition theory and methods of research that second language acquisitionists use to test hypotheses in order to gain additional insight into the underlying cognitive processes involved in learning and acquiring a second language. As such, we have learned about 4 measures of central tendency. We've learned about the mean, which is the average of all scores; the median, which is the midpoint of the distribution where 50% of all scores fall above and 50% of all scores fall below. We also learned that the mode is the most frequently observed score in a distribution. With regard to the mode, we may have distributions that are unimodal, bimodal and even trimodal. There may be some instances in which there is no mode at all. The 4th measure of central tendency we discussed is the standard deviation. The standard deviation is defined as the average variability of all scores in relation to the mean. The standard deviation is one of the most important measures of central tendency that is used when carrying out empirical studies. Once we learned to calculate the mean, median, mode and standard deviation, we learned about 2 important standardized scores used in research, the z-score and the t-score. We concluded our study by learning how to calculate and then subsequently plot these scores on the bell curve. In this video, we will briefly review the bell curve. Using data for exercise number 1 we did for homework, we will look at the relationship between raw scores, z-scores and educational t-scores. Finally, we will review how to plot those scores on the bell curve. In this slide, we see the bell curve. Below the bell curve are divisions denoting the standard deviation points. The standard deviation has a mean of 0, and each standard deviation is 1 point. Standard deviations that fall above the mean are positive numbers, whereas below the mean, they are negative. We also learned that we can make educated guesses with regard to the approximate percentage of subjects in our sample will score between each standard deviation. For example, from a standard deviation of 0 up to +1, we can expect to find approximately 34% of our sample. From a standard deviation of +1 to +2, we will find about 13% of our cases, and from +2 to +3, about 3%. The same percentages are found below the mean as shown in the slide. In this slide, you see the data you used in the homework assignment. The first thing we have to do is calculate the mean, identify the median, and decide whether or not there is a mode. In order to do this, we also had to know how many subjects there were in the sample. In this case, there are 10. The mean for this particular quiz or exam was 11.2. This tells us only one important thing in relation to the bell curve. By knowing the mean, we can mark that on the bell curve. As you can see here, the mean falls in the middle of the curve. The next thing we did was to calculate individual deviation scores or x minus x bar. To do this, you took each raw score and subtracted a mean from it. For example, with the first student, we took 7 minus 11.2 and came up with a final deviation score of -4.2. which you see in the slide. We then did this for every other score in the dataset and the answers appear on this slide. Now, once you have completed this, a quick check to make sure you didn't make a mistake was to add up the deviation scores. If we didn't make a mistake, it should add up to 0, as shown in the slide. Once we have calculated all of the deviation scores, we are ready to square each score to get rid of the negative numbers. As you may recall, squaring a score is simply multiplying the number by itself. So, with the first student, he has a raw score of 7, a deviation score of -4.2, and a square deviation score of 17.64. Now we do this with every other deviation score in the dataset. The answers for the remaining students appear on this slide. Once you have squared all of the scores, you simply add them up. That gives us the sum of the x's that we will use to calculate the standard deviation. Here you see the formula. The formula reads as follows. Sum of the x's squared divided by n-1 and then, you take the square root. This gives us the standard deviation which now tells us more about our data set. I have included my work in this slide. For this particular data set, we have a standard deviation of 3.22. Now we are ready to return to the bell curve to see what this says. The standard deviation tells us how many points are equally spread from one standard deviation mark to the next. So, from a standard deviation of 0 to 1, there are 3.22 points. And from a standard deviation from 1 to 2, there are another 3.22 points and so forth. You will notice that below the mean, we subtract 3.22 points. Knowing the standard deviation, we are now able to plot our raw scores simply by adding 3.22 points above the mean of the raw scores, or by subtracting 3.22 for scores below the mean. So, if a student were to get a raw score of 14.42, he would fall at exactly 1 standard deviation above the mean, as shown on the bell curve. Conversely, if a student scored exactly 1 standard deviation below the mean, he would have a raw score of 7.98. We can also divide standard deviations in the middle to get a rough idea of what a student's raw score would be if he scored 1.5 standard deviations above the mean. If a student scored 1.5 standard deviations above the mean, his score would fall here. Pause this video and try to calculate his raw score. Once you have come up with your answer, press play to continue. If your calculations are correct, this particular student would have gotten a raw score of 16.03. The next step is to calculate a z-score. As you may recall, a z-score is a standardized score that sets the mean at 0 and each standard deviation at 1. You may have noticed that the z-score is the same as the standard deviation scores, with positive scores above the mean and negative scores below. Here you see the formula for calculating the z-score. To calculate the z-score, you take each individual deviation score that we calculated in column 2, and divide it by the standard deviation. The z-scores for the rest of the data are listed in the slide. Now that we have calculated the z-scores, we are ready to plot them on the normal curve. Let's take the first student as an example. This student got his e-score of -1.3. I have shown my work in this slide. Now that we know his z-score, we can go to the bell curve and plot his score. With his e-score of -1.3, we know that this particular student scored below the sample mean. Therefore his score will appear to the left of the mean and falls precisely here. Now that I have the z-scores for the rest of the students, I can plot them as follows. Now we are ready to calculate the t-scores for each student. A t-score is also a standardized score used in both research and in educational arenas. We learned that there are 2 types of t-scores, one that is used for research and the other for education. The scientific t-score automatically sets the mean at 50 and each standard deviation at 10. The educational t-score sets the mean at 80 with each standard deviation at 10 and is the one we will use for this exercise. The formula for the t-score is listed on the slide. To calculate the t-score, we take the z-score for the student, multiply it by 10 and add 80. Therefore, for the first student, we take his z-score of -1.3 and multiply it by 10. That gives us a sum of -13. We then add 80 for a total of 67. This student gets a D for his performance on this particular test. The t-scores for the remaining students are listed in the slide. Now, what we need to do is verify whether or not we plotted a z-score correctly on the bell curve. As you can see in this slide, this student's t-score of 67 coincides exactly with his z-score. I hope this video has helped you learn more about plotting raw scores, z-scores and t-scores on the bell curve. I wish you lots of luck as you master these materials. As always, if you have any questions, feel free to email me.